Hello friends, today I'm going to show you how to make an automatic water tap. Well, in front of me here is my main setup. Well, we have this device here. This is called PRI infrared motion sensor. The PRI infrared motion sensor, this is one that will be triggering a 5 volts relay switch here, and a 5-volt relay switch will turn on the tap or off respectively. As you can see, our PRI infrared motion sensor, we have two knobs here, potentiometers, and one jumper switch here. This one knob is going to adjust for delay, and this one other here is going to adjust for range. It ranges from 3 meters to 10 meters. We'll give it the minimum range 3 meters because we don't want it to have a longer standby current. This one here is our main power driver. I took it off from an old DVD player, and because it's old, you can see it's not properly kept bound. It still works very well. The reason why I chose to use an old DVD player power driver is because DVD power driver usually comes with plenty of pins. All these pins here have different voltages. And each pin here can give a different voltage depending on what we want. Because our array here needs to be powered by 5 volts drive power, we need to take it out from here. We have plus 12 volts, minus 12 volts, we have 5 volts, we have 3.3 volts, we have ground, and we have minus 3.3 volts. You name it, you'll get here. So it's all in one power driver. I don't think elsewhere I can get a wide range of DC output than a DVD power driver. The next thing I want to show you is the tap. This is a tap where our relay switch will be switching on. This tap here, it's a solenoid valve. You can see very well. It's a solenoid valve, and it comes with a gate valve here. This gate valve here is to reduce pressure. This solenoid valve, it can either give you on or off. You can either turn the tap on or off, but it cannot give you various water pressures. So to regulate the pressure, you need to use this gate valve here. This gate valve here is the one that you're going to use to get various pressures. You just set the pressure. It's a one-step set. Once you set that pressure, say it that way, and then you remove the tap. Then you remove the tap, and it remains that way without the tap. See? So that no one will be tempted to use gear valve. Instead, you use the automatic feature. Well, we have another tap here. This tap here is going to be used for override. In case of massive power failure, you can use this tap to override the whole system, and you can still get your water. This is where you're going to plug the main water supply into the tap, so that we can tap into the main domestic water supply. Back to our modules. This is our 5 volts relay switch with an octocoupler and low level trigger option. This low level trigger option, we're going to use it to override the system. If we want it to be normally open or to be always open, maybe you want to hose your car or you want to transfer water into a drum, you just need to change the pin from pin 3 to 2 and into pin 1 and 2. That one is going to make your relay switch to be normally open, and unless otherwise it will stay open until we change it into its automatic feature back to pin 3 and 2. Well, this is a microcontroller, so it's a chain of commands. Command will come from a PRI infrared motion sensor into a 5 volts power array, and from a 5 volts power array it's going to power our solenoid valve, which is this one. So we're going to plug it into our main water supply, and we're gonna see how it's going to work. Thank you friends for watching. This is our setup. This is our tap. It's plugged into the main water supply system, and I'm going to overview the setup. On this side here we have our solenoid valve. It's an electrical solenoid valve. It's controlled by 12 volts per supply system. We have our gate valve. This one is for controlling the pressure or the volume flask, because this tap cannot give you different pressures. It can either give you on or off. And we have this tap here. It's a regular tap. This one is going to be used for manual override. Remember, it's just manual override in case there is a massive power failure. Alright, beneath the tap we have a Red Bull can, and inside the Red Bull can we have a PRI motion sensor. You can see it right there. It is wrapped in a bubble bag to hold it in place. The reason why we are using the Red Bull cap is because we want to redirect the motion sensing capability beneath the tap only, not anyone else within the environment. Well, this PRI sensor is also going to trigger our optocapillary array switch right here, and this optocapillary array switch is going to control our solenoid valve. So it's as simple as 1, 2, 3. That's the chain of command. From the PRI sensor we go to our array switch, and from our array switch we go to our solenoid valve. Beside it we have our power driver. This power driver, I took it from an old DVD, as I said. It's going to give us 5 volts to power our array switch. It's going to give us 5 volts to power our PRI motion sensor, and also going to give us 12 volts to run our solenoid valve. There it is. From there, then everything else will work just well. The power driver is going to get its power from the mains. Okay, now we can turn the setup and see how it's going to work. Set the water. There we go. Alright, that's all. You can use this one. We have this coming on. I take my hands out, it comes off. Red is on. I take my hands out, it comes off. There we go. That's a simple setup, simple tools and simple machinery and simple knowledge, and you have yourself an automatic hygienic tap. It's as simple as that. That's all folks. Thank you for watching. See you next time.